Now let's go south, take a look at the southern South Pacific, significant wave height charts. As of right now, 28-foot seas over a pretty good size area in the central South Pacific. This from a gale about 24 hours ago that generated southeast of New Zealand. In fact, let's go back and take a look at that. Go back to Saturday morning. Seas started developing in association with 45-knot winds there, 34-foot. Quickly ramped up to about the 36-foot range by 18Z and held there. We'll put this, we'll take a look at the Great Circle Pass. This is on about the 205-degree path up into Northern California, the 207-degree path to Southern California, but Tahiti's right here, completely shadowing it. Hawaii, of course, is going to get some sideband energy from this, about 185 degrees or so. Much better exposure for Central America, Costa Rica in particular. The energy is coming right up there. No interference from the islands. And also into Peru. Once you start getting down into Chile, the Great Circle Pass actually start brushing the ice here, and not so much energy in Chile, depending on where you're at. And anyway, this thing sort of rolled out another into Sunday morning, and then here we are with the 18Z run, and it's fading out, 28-foot seas. Still pretty much shadowed relative to California, but maybe just on the verge of coming out of the shadow is at 203 degrees, so that's unshadowed for Southern California. But still pretty much in the shadowy area, 202 or so for Northern California. But anyway, something to look forward to, a little pulse of energy. It would take about 9 days to get into California, so we're looking at a week out during the work week, middle of the week, a week out or so. So something to look forward to. Next, let's take a look at jet stream level winds. These winds help fuel the development of storms and gales and also help direct the travel path of those systems when they do form. What we're looking for is a trough, that is the jet stream pushing north, kind of bowing. That would create a clockwise circulation lower in the atmosphere, which would help support low pressure. Low pressure in the southern hemisphere rotates clockwise, in the northern hemisphere counterclockwise. So we have a little bit of something that could almost be construed to be a trough here. Winds are relatively light, though, barely 100 knots here southeast of New Zealand. This is the leftovers of the trough that actually helped create the gale that we just took a look at. But once you get into the southeast Pacific, a big ridge, pushing well into Antarctica, just completely shutting everything down. No hope for gale development this time in that location. Let's put this into motion. We see as we go out into Monday, a little bit of a trough continues to try to get going. Winds relatively light. This is actually turning into a ridge behind it, so the ridge comes in, it sort of rises up in front of it, forms a bit of a trough, but interesting, there's some wind, but look at this. It's really starting to all turn zonal and way to the south, down around 65 south. We continue that, and there you go. Things are just completely closed off now. Antarctic ice is running right around just south of 65 south, so any hope for development is all inland over Antarctica, winter setting up there. We'll continue to put this into motion. A little bit of a trough here trying to get going 132 hours out or almost on Saturday. But again, the edge of the ice sheet is like right in this area here, 65 or so. Getting little exposure over ice-free waters and play that out. Effectively, it's a big zonal ridge and it continues out 180 hours. Not a whole lot of support for gale development in the upper atmosphere. Let's go take a look at lower levels of the atmosphere. Next, we're taking a look at surface level winds, surface level pressure. The winds blowing over the ocean surface are what generate seas, and seas, as they radiate away from the fetch area, that is the area where the winds exist and are blowing and imparting energy on the ocean surface, creates swell. Swell radiates away from wherever the storm might be and eventually impacts the coast. We've actually gone back in time. We're in Friday afternoon. We want to take a quick look at that little system that formed southeast of New Zealand. Here we go. 40-knot winds into Friday night. 45, almost 50-knot winds. I would put it in storm status as of Saturday morning. Quick look at the Great Circle Pass. It's the winds that generate the swell, and the direction of the winds are what determine the swell's direction. These winds are blowing right up the Great Circle Pass to Southern California, and also to Northern California, 205 there. Not so much to Hawaii. Notice you need to follow this path. The winds are sort of an angle. 30 degrees is about the cutoff where you start really losing size, but still looks like some energy up into Hawaii, and of course Costa Rica also. We sort of been through this before, so we won't go do that again. Anyway, this system pretty much petered out by later Saturday, and by Sunday morning it was all gone. 35 knot winds, you're only going to get 13-second period swell, and 13-second period swell is not going to make the 5,000 plus nautical mile travel up into California. So here we are as of current, a 6-hour forecast. Things really settle down. Ice is running right down around here. Here's another little gale that's setting up 36 hours out. We noticed that in the trough, but it's really small. Doesn't get much purchase. And here comes high pressure pushing down to well to the south here. We can actually show some locations. Here we are. We're down at 58. 62. We're right at the edge of ice there. Anyway, we'll put this into motion, continue on. Notice that all fetch is now way down here to the south. Look at this fetch. There's a ridge here, recall. Winds pushing actually into Antarctica, so nothing too interesting there. We're 100 hours out. We'll continue reinforcing high pressure. Again, we're way to the south. This fetch here, 64, practically over ice. Continuing on, much the same pattern continues right on out. No significant winds. So nothing really in the pipe after the swell that was just generated 24 hours ago. So the outlook doesn't look so great wind-wise going out a week. Let's see if the wave models tell us anything different. And the reality is they shouldn't, because what's really going on here is the wind model. The very wind model you just saw is what drives the wave model. It is input to the wave model. Surface level winds, they just take it, figure out the amount of impact or stress those winds put on the ocean surface, and then they can calculate sea heights from that based on fetch duration, fetch distance, and the direction that it's pointed, and then it's pretty much all straightforward math figuring out when the swell will arrive. So as we continue on, we see here's that little fetch that we saw. We're into Tuesday now, very tiny and shadowed. Doubtful that we'll see any swell from it. Tahiti would do okay. They'd get a little bit of energy from that. But by the time it gets through the Tahitian shadow, probably nothing for California. Costa Rica would see a little pulse out of this. That'd be it. And then here we go. Here's our ice situation again. Just do a quick inspection here. So 64... 61 there, 66. So it's creeping pretty well up. We're well into winter in the southern hemisphere now, and we sort of roll this out, and just not a whole lot's happening. No, there's no real jet stream support, so one wouldn't expect much. Let's go take a look at the long term, see if there's something better in the hopper. First up, we take a look at the Southern Oscillation Index, the difference in pressure between Darwin, Australia, and Tahiti. When the numbers are negative, this suggests the active phase of the MJO. That would mean low pressure over Tahiti. And it would also suggest enhanced support for storm development in the northern hemisphere if it were winter in the northern hemisphere. Right now, though, we're seeing pretty ongoing positive daily numbers suggestive of the inactive phase of the MJO. No indications of El Nino or anything like that getting organized. The 30-day running mean has been creeping up. We're up to 5.5. Not horrible, but not particularly great either. And the 90-day running average is working its way up. It was actually getting pretty negative there as a result of 4 months of westerly wind bursts, etc. Not that manifested itself too much in the SOI, but now we're at dead neutral. So if anything, I'd say we're in a neutral pattern, almost looking inactive from a MJO perspective, and not real supportive of much of anything. And here's a graphical representation of the 30-day Southern Oscillation Index. It too is, pretty much looks like, well, here we go. Back in 2012, we thought we were in El Nino. We got in July, and it worked its way out and turned neutral by wintertime. Then we were in, effectively, La Nina last summer. And then we got to January of this year. The bottom just dropped out. Sure looks like El Nino was getting going. Multiple westerly wind bursts in the West Pacific. But now the SOI has kind of risen. We're hanging in just above neutral. And historically, this is, just kind of where we've been. Nothing too particularly interesting from an SOI perspective. Next, let's take a look at surface level wind anomalies. These are wind speeds relative to normal for this time of year. As of right now, dead neutral, normal trades, and we're looking just about 5 degrees either side of the equator. This is the area that you would look for if westerly wind bursts were to occur and if another Kelvin wave were to develop. No signs of that at the moment. Looking on east, dateline is here, Central America is here, South America here. Again, completely neutral pattern, nothing going on of interest. Likewise, we go out a week, 180-hour forecast. This is the GFS model. This is actually 850 millibar winds. These are winds up 4,500 feet. It's kind of surprising with this model they didn't put it down at the surface, but I guess there's a pretty good connection at 4,500 feet and surface level wind, so they went with it. Dead neutral here, nothing supposedly going on, normal trade pattern. And then as you get into the East Pacific, actually forecast to have easterly anomalies over here. Here's the Galapagos here, the date lines here. This would be expected if a weak version of the inactive phase of the MJO were pushing east and moving out of the way. And let's go take a look and see what's really going to be happening. So here we go. This is outgoing long wave radiation forecast from the statistic model. The orange and yellows are the inactive phase of the MJO, actually more ocean reflectivity off the surface, suggesting clear skies and high pressure. And so a weak inactive phase. The good news here, we're past the peak of it. We never saw any easterly anomalies in what we'll call the Kelvin wave development area here, right around the date line, a little bit west of it. And it's supposed to be all but gone here 5 days out, falling neutral, and with the active phase of the MJO building behind, supposedly. We take a look at the dynamic model. It pretty much suggests the same thing, only it suggests the inactive phase is going to hang a little bit longer, but it also suggests the active phase of the MJO building bottled up in the Indian Ocean and trying to make headway. So this is basically a neutral pattern biased slightly towards the inactive phase, but pretty much a very, very weak pattern indeed. And if El Nino were to be forming, that's exactly what you'd expect to see, is a very muted, weak MJO sort of pattern, but also this time of year the MJO tends to be pretty weak anyway, so one can't say, well, it's all attributable to El Nino. One could probably say it's just more attributable to it being summer now. And here's another view, same sort of thing. So this is the East Pacific would be like right in here, West Pacific would be here, East Pacific in here, Galapagos about here. Here's what we've been through for the past month. This muddled neutral pattern, and the next week was forecast to be pretty much the same as well. So nothing new here. Next, let's take a look at ocean surface level temperature anomalies, differences from normal for this time of year. Clearly there is a warm pattern building of the Galapagos. Right in here in particular looks pretty warm here as well. This is it appears to be in the 2.5 to 3 degree range. We have a little bit more high-res data that we'll show in a minute. And then in the at least 1 degree or higher pretty much the whole way across the equator. This is the classic El Nino kind of setup one would expect to see. The question is, will more warm water be feeding into this area? So what happens is typically the warm water develops here, and then the trades pick it up and start blowing it this way. And as this whole area starts warming, then it starts affecting trades in the weather areas above it. And as it heats, the trades suppress, and then that even allows more warm water, Kelvin wave, subsurface water to start flowing this way, gurgling up off here and trailing off in this direction. And that is really what El Nino is all about. Also notice we have extremely warm water all the way off northern California, this whole area. If you're in northern California proper, or even let's say San Francisco area, you wouldn't know it by being out in the water. It's extremely cold water, much upwelling going on, but it's limited to a very thin slice right along the coast. Southern California anomalies are pretty warm, certainly down into Mexico. Again, this one cool pool here, but nothing that seems to be bothering the supposed development of El Nino. Sort of something that could almost be viewed as a sympathetic warm pool off of South Africa, but nothing marked. I mean, this really, though, is very similar to what one would want to see for a developing El Nino. We're going to make a quick diversion here, look at where we are as of, let's say, the end of May. This is May 20th through May 25th, compared to other El Ninos. And let's be clear, it's very rare to have any sort of a warm pattern developing this time of year related to El Nino. The biggest El Nino of all time is the 97. Here is the image. The next second ranked, again for the May time frame, was the El Nino 57. One must question how you get a satellite-like or model-like data from 1957, but they have some tricks. I'd be a little skeptical on the quality of some of the data, but for rough analysis purposes, it is interesting. Also, we have the 72 El Nino, again, caution on the data, but looks very similar. And then the 2014 El Nino. Notice it's the weakest of all of these. I can't get them all in the... Oh, yeah, there we go. Got all of them. 97, 57, 72, 2014, but all with a very similar configuration, classic El Nino configuration. And this is after scouring every year since 1951, the data goes back to, and these are the four strongest systems for this time of year on record. Now we go to look at some other data. Here is the El Nino from 65. It is just... So the total aerial coverage of the 2014 gave it a bump above this one, though there are pockets of warmer water right here south of the Galapagos. Another outlier here was the 82-83 El Nino. At this time of year, it was not impressive, though it covered a pretty broad area, but that broad area isn't particularly much broader than anything that this 2014 El Nino does. But this one ultimately evolved to be the second strongest El Nino on record, so we included it here for reference. And then the last El Nino that we've seen was the 2009 El Nino, and it had barely any footprint at all in the May time frame. So just a little historical perspective. We're trying to get a sense on what the 2014 El Nino is going to do in relation to other systems that have evolved in the past. And here's yet another view. This is current data. This is daily updated 1 degree resolution satellite-based sea surface temperature anomalies from NOAA, with anomalies using climatology from 61 through 1990. And here we have, here's our, oh, let me get the scale on there. There you go. So this shade is 1 to 2 degrees above normal. And we have some warming going on here that we're going to zoom in and take a look at. But generally, we're looking at 1.5 degrees over the entire Nino 3.4 region, extending actually west of the date line, and much warmer here up along the coast of Peru and the Galapagos. Here's the zoomed-in data we were talking about, and there's actually a little bit of a surprise here. For one, we've all only been thinking that sea surface temperatures were 2.5 degrees above normal, but you can't really argue with this. So this is 1 degree, 2 degrees, 3 degrees right there. Again, play the same game, 1 degree, 2 degrees, 3 degrees with a pocket of 4 degree now, and this is as of just today, and it almost looks like a little bubble of almost 5 degree trying to get going, and then another pocket of 1, 2, 3 degrees down in this area. So clearly warming is developing, and it's all the way down into Peru now, so it doesn't look like so much it's the Kelvin wave, but there's something else going on helping to create this warm pool. So that's going on. At the same time, this area right here is actually decreasing. This was a continuous band, is now starting to back off 1.5 degrees. Maybe a bit to do with trades in this area, dampening a little bit. But for the most part, this is where most of the warm water comes from, Kelvin generated warm water, and then it gets pushed off by the trades this way. So as this pool, if this pool continues to evolve, it will blow off this way and hopefully fill in this gap. Again, Southern California, 1, 2, 3, almost 4 degrees above normal here in Orange County, up into Huntington, that area, and down into San Diego. And then here's that little cool pool that's tucked right up along Northern California and Central California, due mainly to the sudden increase in the gradient and north winds, which is making wind swell, but is also making for 54 degree water temperatures, making it pretty chilly. Big pool of warm water off here. That's been there for a better part of 9 months now. Don't expect any change in that. And the whole region, notice, is about 0.5 to 1 degree above normal. So this is indicative. This is pretty much a classic El Nino kind of setup. Weaker than the big ones, but still well within range of a decent El Nino as of this date and time. One other quick look at surface level temperatures. Again, here we are. The Galapagos are right here. Dateline's off here. Notice this view also shows the developing gap right in this area between 140 and 120. Also note these arrows here suggesting almost light west anomalies. I mean, it's kind of a reach, it's so tiny, but certainly neutral if nothing else. And neutral would almost be enough. You really need some degree of westward movement here. Not a full-on westerly wind burst, but we definitely need something to help push more warm water under the surface and have it heading east. Quickly, subsurface water temperatures, here we go. There's still this downward flow here. Here's the main warm pool, 5 degrees above normal. The Galapagos are right around in here. This really hasn't changed at all. This is classic Kelvin wave setup. This was all due initially to 4 months of westerly wind bursts, January, February, March, and April in the early part of this year. Blowing westerly wind at the ocean surface, it sinks down and then travels as a big bubble and is now gurgling up off the coast. That's probably then worth 4 months of bubble up, which would get us well into the fall, and by then a self-sustaining pattern should be going. If we get any other westerly anomalies, or at least neutrals, just the weakest bit of westerly winds, that would help continue this flow. It hasn't been cut off at all as best we can tell. In fact, you can actually see warm water making the route here, so reinforcing to a certain degree. So this is good news, but a little bit more would be nice. And here's yet another version of it. Basically, this is showing the same thing. Clearly, the path is wide open. Warm water sinking on the dateline, working its way into the Galapagos. So that is not so worrisome. In fact, nothing's really worrisome at this point. Here's the Nino 3.4 sea surface temperature anomaly forecast. As of right now, by the time we get into later October, the model suggests 1.5 degree anomalies. That's clearly El Nino. Even 0.5 degree is considered El Nino. So if you're into the one, the big El Ninos were up in the 2 degree, 2 to 2.2. The other El Ninos that were in the category 4, 3, 5 area, the ones we looked at in previous charts, were all with water temperatures about 1.6 degrees above normal. So this is, if this were to occur, this would be one of the, let's say, the top 4 or 5 strongest El Ninos in the past 60 years, it's going back to 1951, so it's at 63 years. So that would be very solid indeed if it were to occur. The thing we need is to continue to have warm water evolving off the Galapagos, which appears to be the case. If anything, water temperatures getting warmer by the day in that region, and then have it drifting off to the west. So as of this point in time, all is on track. What we really want to see is another westerly wind burst in the over by the date line. Don't really expect to see that, but what we would like to see is at least seeing trades suppressed. And finally, in that vein, the 200 millibar 40-day forecast suggests the inactive phase of the MJO is in fact over the East Pacific. We saw east anomalies there. That's supposed to basically be gone by the middle of June, and at that point in time, here we go, inactive phase. Week 1, marching its way across the Pacific. That would be just in time to maybe stir up the weakest sense of west anomalies for, from mid-June into early part of July. Maybe good for some westerly anomalies. And then after that, even kind of a muddled pattern. It just continues to get weaker and weaker. This is exactly what you'd want to see, so that by the time you hit August, that's when you start getting into the change of season. That's when the MJO is kind of dead, but what happens is if El Nino was in play, it would take over. You'd start seeing westerly anomalies. We'd start seeing tropical development in the West Pacific and see those storms actually recurve and start heading towards the Gulf of Alaska into as early, the last big El Nino, August 15th is when we saw the first one of those systems, and by September or so, you would see stronger ones and better ones if this were a significant El Nino developing. But we're getting a little bit ahead of ourselves, but the main hope is that there is in fact an El Nino developing, and all the data seems to support it as of this point in time. So that's our forecast for this week. Hope you've enjoyed it. The short news is wind swell for Northern California, southern hemi swell about a week and a couple of days out for California, less so for Hawaii, about a week or so maybe for next weekend. And again, energy also into Central America. And many thanks to our sponsor, Vunubaka.com. Check them out on the web. Great surf and residential community going up in Fiji. Check it out. And we'll do this again next week, same time, same place. Thanks for viewing. Bye.